Welcome to One Chemistry. Always try to do your best. Now let us see about 100 conversion in organic chemistry. We are seeing it as episode. This is episode number 56. If you didn't watch previous episodes, I encourage you to go and see. Here we solve 5 problems step by step. Stay tuned. Let us see the question number 1. Question number 1, starting metal contain 5-member and 6-member fused system, and the fused ring you have the alkene there in the bridge. So you have reagent NBS and water, you have potassium carbonate, BF3 and the ether there. Here products are given. Products are just ketone formation or fused ring alcohol formation, or the position of alkene is different. The D answer suggests that there can be a ring contraction and ketone formation. So from the question and answers and reagents, you might understand that ring contraction possibility as well as the position of double bond is a real question. The answer is D. Let us see how. The starting metal you are using the fused system, you are using the N-bromosuccinimide. N-bromosuccinimide is a brominating agent, it supplies the bromine. Bromine attacks the double bond, form the bridged bromine. Here bromine addition is syn addition, meaning both bromines are in the same side. It can be either above or below. Here it's shown as above for convenience. Then you are adding the water, it's a SN2 reaction, so ring will be open due to the strain. The attack is from the back side. Since it is a SN2 mechanism, attack is from the back side. So you have OH below and Br above. Then you have trans Br and OH. So there is a possibility of intra SN2 reaction because the bromine is a good leaving group there. So OH attack from back side. You have backside epoxide formation. Here oxygen is on back side. Next step you are using the acid, which is a Lewis acid, and ether is the solvent. Then it is weakened the oxygen on the bridge. Then the bridge will be opened by the movement of trans-methylene group. Here epoxide ring opened by the trans attack. The ring open, cation remain there. So the cation has to be quenched by the ketone formation. BF3 leaves there. So finally you have a contracted system. Here you have to learn two things, which is NBS. NBS is the brominating agent. Second thing is the ring opening is SN2 type. Always you have backside attack and inversion in configuration occurs there. Then the question number 2. The starting metal is benzene attached with amine. Amine has continuous functional group attachment, which is ketone and hydroxylamine. Here you are using the acid and ketone and titanium tetrachloride and zinc. Here 4 products are suggested. All products are contain the ring closed one with nitrogen, where the both nitrogen involved in the ring formation are one nitrogen, as well as you have the ketone incorporation also. So the position of phenyl also real question. So from the question and reagent you might guess it's a naming reaction, and ring closure definitely occurs there. The answer is B. Let us see how. The starting metal contain oxime, you are using the acid. So you might think of Bachmann rearrangement. It's a kind of initial step of Bachmann rearrangement. So it's not really a Bachmann rearrangement. So water elimination occurs, H2O leaves and CN form there. After the CN formation, you have the possibility of ring closure. Always ring is stable than linear chain. So ring stability achieved there by new ring formation. So what really happens is nitrogen donates the lone pair and double bond moves. New 5-member ring formation occurs there. Then the next step you acquire the nitrogen positive charge. So to quench the positive charge as well as to establish the aromaticity, the hydrogen leaves, aromaticity occurs there. Then you have aromatic system with NH there. You are doing the hydrolysis. During the hydrolysis, amine becomes CO, that is the ketone. So next step you are using the ketone and titanium tetrachloride and zinc. So you have 2 ketones and you have phenyl ketone there. So you might guess it's a McMurray reaction. McMurray reaction is very interesting one because you are establishing the carbon-carbon bond between 2 carbonyls. You end up with CC double bond. So 1,2 carbon combine and establish the bond between itself. So the answer is clearly B. Here you have to learn 3 things. One is cyclization is a driving factor initially. Second, aromaticity. Aromaticity drives the reaction for the ring closure and annulation. Third, McMurray reaction. McMurray reaction combines CO and forms CC double bond. Then the question number 3. The starting metal contains benzene with aldehyde and one vinyl group there. Here you have another reagent which is dibromide and you are using the zinc. Then you have reagent TPDMS, pyridine and DMAP. You are using the palladium with phosphine. Then you are using base and cyanide as the solvent. Here products are given. The products are mostly ring closure and position of DPDMS is real question there. Then there is a possibility of ring expansion as well as the symmetrical addition to establish the aromaticity. So 4 products are different in one cause. You have to guess it accordingly. So from the reagents you might guess it's an amine reaction and definitely cyclization occurs there. The answer is A. Let us see how. Here you are using the zinc and you have bromine in the starting material. You have organo-zinc compound which is the anion generator. Here 2 bromines are there but only one bromine reacts. Why? Because the bromine attached with the sp2 which is double bond is very stronger one. So the free bromine which is sp3 reacts there. Organo-zinc will be formed there. So the anion will be established on the bromine. It attacks the carbonyl there. So new CC bond established between the system and again one bromine is there. Then you are using the TPDMS and DMAP. The role of DPDMS is to protect the alcohol. DMAP prevent the dehydration of alcohol. These 2 reagents you should not confuse. The 2 reagents have one purpose, just to protect alcohol. Then for cyclization you rewrite the starting material. Then you have palladium and phosphine. You might guess Heck coupling. Heck coupling, what really happens is bromine attached with palladium. You have new CC bond there. That's why it's called coupling. So the DPDM must not remove there as suggested in product. So the product is clearly A there. Here you have to learn 2 things. One is DPDMS and DMAP. Both protect the alcohol from any sensitive reagents. Second thing is Heck coupling. If you have alkyl halide with double bond, you might guess it's a Heck coupling. Then the question number 4. The starting metal is fused to 5-member system. You have conjugated ketone and many methyl group around the system. Here both hydrogens are above the plane on the bridge. Here your reagents are sodium borohydride, ceria chloride and methanol. Hydrogen addition with iridium complex. The next you are using the phosphine reagent and acid and DET reagent and lithium aluminum hydride. Here 4 products are given. 4 products are same but only differ in the stereochemistry. Whether the OH is above the plane and below the plane, how methyl groups influence the reaction. So you might understand from DET reagent, it is an amine reaction. So the reaction is the play between stereochemistry versus reactivity. The answer is A. Let us see how. The starting metal is the ketone. You are using the sodium borohydride and ceria chloride. Basically it's the reduction. So the Cramp's rule applies there. So H attacks the less hindered carbon. You have the OH below and hydrogen above. The hydrogen attacks the same of the other hydrogen. So H above, OH below. Then you are using the metal for the reduction. So syn reduction obviously happen. Because metal has chelating property, reduction is always syn there. So syn hydrogen added there. Next step you are using phosphine, acid and DET reagent. So you might guess it's a Mitsunobu reagent. The reaction is called Mitsunobu reaction. This reaction is like SN2 but inversion in configuration occurs there. So the OH is below the plane. After the reaction it will go above the plane. It's an inversion in configuration. You have the ester attachment there also. Then the next step you are using the lithium hydride. It remove PHCO there. So you have final product is alcohol. All hydrogen and OH is above the plane. The answer is clearly A. Here you have to learn many things. One is Graham's rule. Graham's rule suggests hydrogen attack less hindered. Second thing is the syn reduction of metals. Metal forms chelates always promote the syn reduction. The third thing is Mitsunobu reaction. Mitsunobu reaction always the attacking carbon get inversion in configuration. The reagents are DET and phosphine and acid. Then the question number 5. The starting metal is long chain system with acid, aldehyde and ester. There are the 4 functional groups here. One is alkene, azide, ester and aldehyde. You are using the phosphine and sodium borocyanide there. Here products are given. Products are mostly cyclized one. You have to guess the ring size or fused system, whether it's a 7 member, 5 member or 5 member with long chain. So from the reagents and starting material you might guess it's an amine reaction, and definitely cyclization occurs there. The answer is A. Let us see how. The starting material you have azide, you are using phosphine. So there is a possibility of Stardinger reaction. Stardinger reaction, what really happens is azide convert into amine there. So it's a Stardinger reaction. If you want to explore further, you study the mechanism separately. Here N3 converts into NH2. Then you have amine and both side carbonyl groups are there. So aldehyde is there and ester is there. Ester is comparatively less nucleophilic because of its O-methyl. O-methyl is an electron donor, reduce the positive charge on the carbon. So it reduces there. So the positive charge less in ester, high in the CHO. So CHO will be attacked, new 7 number ring is formed. New 7 number ring contain amine and alcohol at 7th position. The 7th carbonyl become alcohol there. The next step, you are using the reducing agent. The reducing agent is very selective because it will remove the OH, not COMe. Because it's a mild reducing agent, only remove the alcohol there. You have finally 7 member system with nitrogen, heterocyclic system. Other products are untouched. Here side chain given for confusion, particularly because of the selectivity. Here no participation of the side chain. Here you have to learn two things. One is Stardinger reaction. The Stardinger reaction converts N3 to NH2. Then you have to know sign of sodium borohydride, which is a cyanide derivative of sodium borohydride. It will only remove the OH from the system. It will not disturb COMe or alkene there. That's all from this episode. I hope it was useful. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.